in this video we're going to talk about absolute value and square roots. So the absolute value, or you could think of it as just the value of the number, is its distance from 0 on the number line. Now distance is always positive. You can't have a negative distance. You can't go -3 miles to the store. It doesn't make any sense. So distance is always a positive number. So the absolute value is defined as a distance, because what the absolute value does is it takes any number inside these absolute value bars and it makes it a positive number. So for example, the absolute value of -10, because -10 is 10 units away from 0, is +10. And then an absolute value of a positive number, that number just also is positive, it stays positive. So think of it this way, is you're going to go to the store and it's 10 blocks away. It doesn't matter if you go this way or this way, if you go north or south or east or west, you're still walking 10 blocks. It's the distance that you went, not the direction that you went. Okay, so every negative sign inside, now this just operates on a single number. Think of it, one student of mine used an analogy of a car wash. Okay, you can only have one car in the car wash at a time. You can't have like double wide. It's a single wide car wash. And what it does is it washes off any negative signs. So this absolute value of -6 is equal to 6. We might also have a negative on the outside of the absolute value. And the absolute value does not operate on the outside of it, only what's on the inside. So we have -16 inside, so the absolute value of that is +16, but we have this negative sign on. Our answer will be -16. So you might think, oh, 2 negatives, that makes a positive, but not the case, because these are not parentheses, these are absolute value bars. So that absolute value is a function that operates on the number inside. -16, the absolute value of that is +16, and bring the negative sign down. Okay, we've got 2 more of these. Now here we have an operation first. So the absolute value does not operate on 2 cars wide at the same time. First we need to do our order of operations. We need to find this value inside first. So I'm going to do -11 minus 6 and put that answer inside my absolute value bars. Okay, I have a negative minus a negative, so I'm going more negative. So this is -17, and then the absolute value is +17. Okay, here we have a multiplication on the outside. Just like with parentheses, if you have a number right up against the absolute value bars or symbols, that's also multiplication. But we need to do what's inside first. So I'm just going to bring down the -2 and the absolute value bar. 11 minus 20, so $11, but I need to spend 20, so I'm short by 9. Absolute value of 9. I can put my equal signs here. Now I do the absolute value operation. I still have -2 times +9, because that's what the absolute value does, makes it positive. And the answer is -18. Okay. Okay, let's do a few square roots. So a square root, what that's saying, this is the symbol right here. The square root is saying what number times itself equals the number inside the root. So what number times itself equals 81? And that is 9. Move this up. Now we have a negative on the outside, so we're just going to bring that down, and the square root of 100 is 10, because 10 times 10 is 100. We can do the square roots of fractions in the same way. We're going to keep the numerator and denominator separate. So we do the square root of 144, which is 12, and the square root of 49, which is 7. So this is equal to -12 sevenths. And we can just leave it as a fraction. Now, you might be wondering why can we do the numerator and denominator separately? And that is because if we remember sorry, I don't really want the negative in there. I just want to do the 12/7 because we're not multiplying negative 12/7. Remember, when we multiply fractions, you go straight across. You multiply the numerators and denominators. So 12 times 12 is 144, and 7 times 7 is 49. So you see how if we squared 12/7, then we would multiply it by itself, and the numerators and denominators stay separated from each other. Then this problem is saying, what's the opposite of the square root of that? And so that's why it's negative. Okay, a couple more here. This is the square root of 1 over 36. So again, we're going to do them separately. Square root of 1 is 1, and the square root of 36 is 6. So that is 1/6. Okay, let's look at the square root of a negative number. So we had negatives on the outside, and that worked just fine. What about on the inside? That would be saying, what number times itself is negative 36? So can you think of one? If I take negative 6 times negative 6, I get positive 36. And if I take 6 times 6, I get positive 36. The only way to get a negative is to take a negative times a positive, but then we're not squaring anything, because squaring is a number times itself. So there is no way to get this answer. So we say this is not a real number. And when you're doing your homework in web work, just be sure to read around the question, around an entry box usually, of what to type in. This will probably be DNE, which stands for does not exist in web work. Okay, but just read right by the question. It'll tell you what to answer, what to put in. Okay, another one. Let's look at B here. So this is the opposite of the square root of negative 81/100ths. We have the negative on the outside. Can we cancel out these two negatives? No, because this is a square root operation, which operates on this first, just like the absolute value did. We have, like on this one, we had to do this square root or this absolute value operation first before we could do that negative on the outside. So again, because we have a negative on the inside, which is called the radicand, because we have the negative on the inside, there's no way to get that number with a perfect square, so this is also not a real number. And you would write DNE in web work. You wouldn't put DNE on a test though, because the more mathematical term is not a real number. We'll be looking at the different number sets coming up, and that will make a little bit more sense then. But as far as the computer goes, there are certain symbols and codes that we need to enter in. Okay, one last thing for the square roots. Let's just make sure you know how to find the square roots on your calculator. Use a calculator to approximate the following. Write your answer with 4 significant digits. And that's because in web work, to have the computer mark it correct, it wants 4 significant digits. So that's for web work. Okay, so you've got to know where your square root button is. Mine is down here. It's on the x squared, which is cool because those are actually inverse functions of each other. So taking the square root is the opposite of squaring something, and so they tend to put inverse functions on the same key. So instead of the squaring, we want the square root, so we need to use the second button. So I'm going to go second square root 10 and hit enter. Now you might think your calculator is broken when this happens. The reason is it's programmed to keep the answer exact. Square root of 10 is an irrational number, so the decimal is going to go on and on and on forever. However, we want the decimal approximation, so there's a button for that. And if you have a different calculator, you have a button for this somewhere, or it might just automatically give you the decimal. The button on this calculator is right here. With this, the arrows back and forth say it's changing forms, changing from the exact form to a decimal form. So I just push that button and I get 3.162, and I'll use the approximately equal to. That is for significant digits, even though 1 digit's before the decimal and 3 are after. That doesn't matter, it's just the 4 digits. Okay, let's try the 80. Now we could put in the negative in our calculator, or we could just know it's going to be a negative answer. Either way, I'll do it both ways. So again, square root 80. I'm going to hit enter first, and then it does simplify this, which you'll learn in Math 65. And then we've got our answer. So remember to make it negative. Negative 8.944. Okay, now if you wanted to do the entire thing in the calculator, you would use the negative key, which is way down at the bottom. It's not the subtraction key. The negative key is a little bit smaller and it's up higher than the subtraction key. You see the difference? With subtraction, it's expecting an argument before it, so that's why you can't use them interchangeably. Okay, negative or opposite square root of 80, and I need to get the decimal approximation. It puts a negative in there for you. Okay, and then one more. The square root of negative 72, I don't think we can do that. What do you think will happen if you did put that in your calculator? Let's just try it out. Square root of negative 72, domain error. We can't input a negative into a square root function, so that's why it's calling it a domain error. So we can't do that. So this is just like 16 A and B. This is not a real number. Okay, so that is absolute value and square roots. So I'll see you in the next video or in class.